Hi and welcome to our next level 2 calculus video. Some questions in the exam often ask when are functions increasing or decreasing, and we're going to talk about that in this video. Right, quickly remember that maximum and minimum turning points are points on the curve with zero gradient. Maximums occur when the gradient goes from positive to negative. Minimums occur when the gradient goes from negative to positive, and all of them have a zero gradient. Right, a region in a function that has a positive gradient is said to be increasing. The graph is increasing because it's got a positive gradient. A region in a function that has a negative gradient is said to be decreasing. It's going down, it's got a negative gradient. So for this example here, you can see here's the maximum and minimum turning points. Here's a region that has a positive gradient. So this region of the graph is increasing. Here's a region which also has a positive gradient, so this is also increasing. And this is a region of the graph that has a negative gradient, so this region of the graph is decreasing. Right, so let's look at an example and show you the kind of question they may ask. For what x values is the function y equal to x plus 3 bracket x minus 1 bracket x plus 2 increasing? Well, it's a cubic, it's 3 brackets. The first thing we're going to do is expand out the 3 brackets. And if you haven't learned how to expand 3 brackets, you need to go and learn how to expand 3 brackets to get it into the polynomial form. Second thing we're going to do is differentiate it to get the gradient function, 3x squared plus 8x plus 1. Right, we're going to put the gradient rule equal to 0 because turning points have a 0 gradient. And this is a quadratic equation, so we need to use the quadratic formula or our calculator to solve it. The two solutions are negative 0.13 for x and negative 2.54 for x. If you wanted to find the y values, you could go back and substitute each of the x values into the y rule and work out what are the y values to get the actual coordinates of the turning points. But we don't actually have to do that in this example, so we're just going to move on past that. All right, here's my x-axis, and I know I have a turning point at negative 2.54, and I also have a turning point at negative 0.13. All right, let's start off with a value on the left-hand side of my first turning point at negative 2.54 and substitute this value of negative 3 into my gradient rule, and I get a gradient of 4. That's a positive number, which means it's a positive, it's going uphill. I'm now going to pick a point on the other side of the turning point, maybe negative 2, and I'm going to substitute x as negative 2 into my gradient rule. And after working that out, I get a negative 3, which is a negative number, which means I have a negative gradient in this region. And finally, I'm going to pick a point on the other side out here at maybe 1, and I'm going to say, what is my gradient doing? So I'm going to substitute 1 into my gradient rule, and I'm going to get a gradient of 12, which means it's back to being positive. So the graph looks like to be doing this. In this region, it's going positive, uphill. In the middle region, it's going downhill. And in the third region, it's going back uphill, positive gradient again. So to answer the question, look at what the question actually said. For what x values is the function increasing? We can see it's increasing when x is less than negative 2.54 on the left-hand side of that turning point. And we can also see that it's increasing when x is greater than negative 0.13. Anything on the left-hand, the right-hand side of that turning point. Great, thanks for watching.